different thing on the ground, the material, the wire, the cable, and this box. Can you simply tell me for what?
Yeah, basically these 5 horsepower DC and AC operation. Yes, and it's an auto strapper. So these are 3-phase pumping machine. So the AC side of this have been connected, as you can see, has been linked to the powerhouse. Then we are here to connect the DC side of it. That's the solar aspect. So this goes solar and direct lights. Yeah, that's what I mean by AC and DC. So that means to connect the solar into it, you don't need battery. Just connect from the solar panel to the MPPT.
So that's the box we have.
Yes, of course.
And this is the bulb.
Exactly.
Okay. I think that's very clear for now. So that means it's going to be used during the daytime.
Yes, during the daytime. Here we have 24 panels. Because now each of these panels is 8 volts, unlike regular panel. So, and this we need at least a minimum of 500 volts for this extra combination to work. So that means if we do the calculation, let's do the math together. There's my calculator. So 248 volts times 12. That would give us sorry, I do divide 48 volts times 12 and give us 576 volts. That's what the pump needs for a start. But now because we also need amps, so that means if we are to series all these whole 12 panel on one row together, the boss will see the entire 12 panel as one panel. You understand, because it's series. So we also go to series together 12. Then we will now parallel it together. So it will not see the whole 24 panel as 2 panel.
So one side.
Exactly.
So how did you manage to determine how many volts it will require to power this?
Yes, from the nameplate. There's what we call nameplate on it. It is written on the body. If you look at the what we call a VOC and a VDC. This is the AC input. It should not exceed the 380 volts of the VOC of the panel of the lights. But the VDC, which is the panel DC, that's the side of the panel, the right input voltage, it should not exceed.
Okay, I'm saying 750.
See now, it should not exceed 750 volts. While we are doing 500 or something volts of it. You understand? We're doing 500 or something volts with that 48 volts times 12. That gives us 570 something volts. So at least between 500 volts to 750 volts.
To be in between.
It will be in between.
What will happen if it's more than 750?
It will burn the system. It will be over voltage.
So what of if it's less than 500 volts?
At least 400 volts is still okay. Between 400 volts. And if you look at the VDC, for the AC, it should not exceed the AC own. The AC own is 380 volts. So
okay,
from 380 volts to 700 volts.
So which means 400 is still okay.
Still okay.
I think it's clear.
All right. So well done. Yes, sir. So back to the panel section for the sake of some of our students in our academical class on our Prayer Academy. So regularly, solar panel comes in 24 volts or 12 volts, but this particular one comes in 48 volts. We use meter to read, but this is the positive, that's why I have the red, and this is the negative mount. Okay. Bring that meter for me, Fisayo. Let's read.
So which means this volt now is double of normal.
A normal regular
volt
standard panel, which is this is 300 watts panel. It's probably 250 watts, 300 watts. Let's count the cell. That is monocrystal light. How do you determine the cell? Look at the diamond shape. You count 1, 2, 3, 4, 5, 6, 7, 8. And you now count it. 8 in that row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it will be 8 times 12. So let's do the math. 8 times 12. So that's 96 cells. So the total number of the cells on the panel is 96 cells, which is good. Bring the meter, only the meter. This way. So now let's read the VOC. We have VOC, which is open circuits. Open circuit means when there is no load on the panel. That's a VOC. But when there is load, it becomes a VDC. Now, what is the VOC? The VOC is 51.6, 51.7. So that's the VOC of the panel. But the actual nominal voltage is 48 volts. You understand? So when you load it now, this VOC will now drop to the normal VDC where they have carried load. It is therefore within the power rating of either 48 volts or 47 volts, which is still a good one. So
For each of these panels.
for each of the panel, so which is better? So each of the panel we are going to series them. On the series aspect of it,
What do you mean by series?
good. When we say parallel, that means this is going to be the carrier cable, so that we will link all the panel together. Now, what we mean by series, I mean that this is positive of the second panel, and this is the negative of this first panel. So I bring it together. It's now series. So these two panels now is now one. They are now one. This will not be the end terminal that will come to this wire here. Then on this side, I also series these two together. This is what we mean by series. So these three panels are now one. That's what we mean by series. So on this other end too, we series this. It became one. Then here, we series this, it become one. So you have to replicate the same thing for all the panels. It became one. It's easier because they are going to use scaffolding on this place, just like we have on the other side. So this is an emergency mounting for now because of resources. Urgent need and some, you know. So that's also common. So that's receiving all the old 12 panels. So the last one is, so now we don't have the end terminal here now, which is negative, and the terminal there too is positive. Are you confused? Good. We have the end terminal here negative, so this 12 panel now is now one panel. So now, since we have negative here, so if I were to series this side, I also make sure that negative should be here. So that in case I want to either positive or negative, any of them can be. Since it's two wire that is passing inside. I will use one. I will use yes, of course. Let's continue. Let's negative be here.
So you are using negative or positive now?
I'm using negative. It doesn't matter which one ends. So we also parallel. Also series this side. Moga, that's our Shiva accountant. We like money. Okay.
So can I join you? Please, do.
Yes. Aha.
It's going this way.
Yes, yes. It's not hard though. Aha. Then do the next one.
Okay.
Okay. Then the next. Okay. I'm doing well.
So I'm getting this one small.
Very well. Not small, will be big. Let's be broken. Yeah? you have everything now. But we see when we get to the DC breaker side. This one now we're only configuring for now. When we want to connect here, we'll talk about the DC breaker. I think they are going to leave it here, right? Or where are they connecting the? Where are they mounting it? Okay, they are mounting it on that pole there. Okay. Have you got to the last end now?
Yes.
Aha. Now see now. We have positive, negative, negative over there. So at this end now, these two positive will be joined together. We need a plier and insulator tape.
So this one all together one.
Yes, this one is one. This one is one. So
12,
now we're not going to
12,
make it two now.
12 self for each side.
Yes. Now when you now take the positive from this side to the positive to this side, so it became two panel. That's what we call parallel. But now we have series one side of the panel. We have also series the other side of the panel. Now we didn't come with the. So do you have a where is red tape? Do we have red tape there? Drop that black tape down. Bring the red tape.
Why not using black?
Because no, doesn't matter. I want to do what we call color coding. So I'm going to tile red tape on it to identify that it is positive. In case next time someone wants to come and work here, or I send some of my staff here for where they want to mount it on the scaffolding, on the way which they are yet to build. So we'll be able to draw a color coding. Or maybe there is challenges, so I can be able to tell them that this way the positive.
So they're able to rectify it.
Yes, where the positive athletics and
so color coding is very important in installation.
It's very, very important. Very, very important. So, all right. Where is that right? Give me the other one. That one have more, right? Okay. You don't need much. Just to hold the insulator. So have this. So here we have the two positive terminal. So for something we also be very careful. Although this wire they put is very small, this 6 mm, I was expecting them to have nothing less than 10 to 15 mm cable, but maybe because their procurement departments, they were in a hurry, let me give them an excuse on that. So maybe that's what they go for 6 mm, because they don't have enough wire on that. But we are coming for the upgrade. We increase the size of the wire, this cable, to 15 mm. You understand?
So does that mean this and 15 mm cannot perform the same?
Yes, it will perform the same, but now you're having a high voltage flowing through it, and that can really damage the insulator of the wire when it gets hot, and there can be breach. And when there's a short circuit, you know what that means? That can damage the cells of the panels. And we also have some of devices at the back of the panel, those diode, resistors, and all that, so they can also get damaged, which will decrease the performances.
So to be on safe side is to use 15 mm.
Yes, to use 15 mm. But the cable will definitely won't get hot. Sorry. The cable stripper. Alright. There is a pure copper DC cable. But we just have to make use of what they provide for us for now.
Because of the need.
Because of the need, as they requested. Or on the normal circumstances, I don't encourage 6 mm cable for this kind of installation because this is huge. So this, give me the black tape. We are going to connect the other terminal, the negative terminal at the other end. Then we now do the reading. So they also have to put 18 on the panel, but because it's not on the ray, those panels are supposed to be bind together and should be 8 in case of a cloud discharge when it's thunder. Yeah, so the 8 arrestor we took the excess voltage to the ground. But we are not doing those today. Okay. This is fire. Then you understand what I'm saying when we get to the other end. Like this is fire, don't try at all. All right.
But why are you closing the other cable?
This one, so that it won't contact. There's going to be light when we connect it to the other side. It will be an energy flow. So to avoid short circuits and surge and leakage, so that's why I'm closing it. Alright, just temporary usage for now. So let's go to the other end. You get me the digital meter. So at this end, we have the negative terminal. So I have to put it together. Yeah, let's put it in. Right. So the reason I separated negative, two negatives to be here is to avoid situation of reverse polarity, like taking the polarity of negative to positive. Okay. Yes, so that's another reason. Of course. Yeah, so now I'm also doing a color coding for it. See, I'm using the black tape to color code this negative. Let's have a meter here. Put this on it, please. Usually we have our electrician knife that we use where it's quite unfortunate we didn't take it. Yes, we didn't take it. We thought we were going to make use of the existing installation of the panel, but when we get here, they didn't tell us that they are putting the new panel. So that's why we didn't bother. We were supposed to terminate and connect. So, but I didn't know that they get a separate DC pumping machine. So we thought we were working on the existing pumping machine that we pump it. They have 5 kVA there. So I thought they were changing that to this. Yes, I never knew that the dog. Yes, I never knew that the dog another hole here. Yes, so that they can harvest as much energy they need from the sun. So this is negative to negative. So this 12 panel and 12 panel are becoming 1, are becoming 2. So instead of 24 panel now, it's the system we see it as 2 panel because we have we are running on series and a parallel. Now, why is it okay for me to play this wire this way? Is because it's only the positive terminal that is connected to it. So there's no hazard yet, there's no harm on it yet. There's no hazardous for now. Okay. So this second layer of the wire This is actually basically used for the earthing. But we are not going to use, even though we want to even earth the panel, we're not going to use this wire because this is an industrial. So that's to run our separate earth cable for it. So here, let me isolate this conducting material first. Bring those two wires on the ground for me, bro. Be careful about it. This knife can shock because the voltage is high, so nobody should touch that wire. I'm even me touching the positive. I'm already having a tingling effect, even with my shoe. So please be careful.
Don't play with it.
This is fire. Do you know one way you can know that this is fire? Are you sure you can wait?
So you are feeling it?
No, but I've isolated that earth wire that is there. Now, what happened? You see that bone?
Yes.
It's fire. Because this is about 500 volts. This is going to 700 volts because of the VOC of the panel. Tell me what we get. 607 volts VOC.
And
that's close to 750 that we are looking for. So because of the VOC of the open circuit of the panel. Okay, give me the right tape. Let me call this 6 mm.
so what do you want to use that one for?
This will be the carrier wire to the system. But they should have a this breaker that will be noise you. The right tape. So basically we are practically done with the configuration of the panel. So do you have any question?
Well, I'm seeing the miracle here when the fire comes out. So which means that is what happened to some roof, because there was a video I watched that the panel on the roof, this installation that we are doing on the ground was done on the roof.
Yes.
He said then there was outbreak of fire. So
Yes,
why?
the video go well fire. Thank you. The reason why the roof caught fire is because of a quack engineer. I didn't know what quack engineer. So many people are not working on this business. They fed it, it's just panel components. For you to do a solar panel, it's just like what we do, we calculate the power rating. What's the power rating of that pumping machine? What's the power rating of the solar panel? Now, what is the minimum voltage of the pumping machine from 380 to 750? The VOC and the VDC. So you understand that first.
So those information are very
Before
you start any
installation.
So failure to understand that can lead to...
It is very hazardous. It can damage someone's house. So when you know the information of what is the size of my inverter, what is the KVA, and you start with your load, what is the load I want to power? That will determine the size of the inverter.
What do you mean by the load?
The load will be your light, your fan, your
pumping machine.
Now we are doing pumping machine because this is already programmed to be used by the pumping machine. Now, this pumping machine is 5 kVA pumping machine. That's 5 horsepower pumping machine. That is what it is. And this is 4,000 kilowatts MPPT. So that means we have to generate 4,000 kilowatts energy minimum for that pumping machine to work efficiently. maximum to work efficiently. So now what does it need to achieve that 4,000 kilowatt? We need voltage. What is the minimum voltage? Because it's 3 phase. You have red phase, yellow phase, and blue phase. It doesn't have neutral. So the problem is if it's neutral, this side to the shape. So now, for the DC part of the solar from that pumping machine, that's where we're having the solar configuration that we are doing. That DC part now, we are to configure our panel to a minimum of 380 volts to maximum of 750 volts. But now we don't want to go to 700 because we want to be on the safer side. That's how at least we reach our peak mode of 606 volts, which is a high voltage. Sorry, close to these dangerous things. So now why did panel caught fire? Number one, cable. Complain at the moment that it is too small. You need not less than minimum of 10 mm to 16 mm.
But this size is how many mm? 6 mm.
This is 6 mm. So they are able to upgrade it.
So this is the smallest size of
we have a
solar.
we have a 2.5 mm of DC wire. You understand? We have 2.5 mm. That wire there is AC wire. You understand? But why this one is DC wire? They do two different working entirely.
So what determines the size of mm you use for installation?
The thickness of the wire. The thickness.
Okay.
The thickness of the wire determines the mm. You understand? So the thickness of this wire is 6 mm.
So no, my question is this: what determines the size of mm you will use for any installation?
There is the number of the panels.
You want to
That
install?
I want to install. If I'm installing 6 pieces of panel, you can go with 6 mm. That's fine. But if I'm doing it from 12 panel, at least 10 mm is okay. For a 6 mm you can see under the 12 mm, 10 mm is okay. Yeah. Or
Sorry,
16 mm.
please.
Sorry, please.
Okay.
Or 15 or 16 mm. So if you notice, at the dead end of the two sides of the wire, I've insulated it to avoid just circuits. That's why I insulate the two marks here. That's the dead end. So when we connect the sides, so we don't have any breach. This one.
You are still going to open that
I'm still going to open it when
there is need.
the main power usage. If inside your one means go and check whether Mr. Aziz is asking for the breaker. Alright, let's test our fire again. So do you see why roof burn? So now, another thing that causes roof burning is that people, when they are doing their termination, they don't isolate it very well with tape, and there will be leakage. And you know, roof is a conducting material because of the metal of the roof, and that can trigger spark and can trigger burns. So, first thing is make sure you scrape your wire very well and you twist it properly. When we're having fire here, I think I just use it. Where is that? What is it? I think this has to do with the ditch. So we have this. So as a
This
proper,
must be tight very well.
yes, you have a proper gripping. But there are other devices you can use, cable connector, cable lock, and all that. Yes, we have C2, C3, we have it on different ratings that you can use. But if you, there's a need for you to pin it because we have to improvise when you're on site like this on emergency situation. But make sure you tighten your cable very well to avoid see that the insulator I'm using on the tape, and even this just that we are not using our but make sure you use whenever you make use of this. Yeah, have to be honest in that aspect. Okay, notice I break the wire. Like you have a proper grip of it when I squeeze this.
That's the question I was about to ask.
Because of rain,
Because over time, this is open.
there's going to be a vibration. But everything is just less than a few weeks for use. For maybe 2 to 3 weeks, when they're ready for proper installation, they'll come and dismantle it and reinforce it. So what did he say?
Take the power out of the
Okay, all right. Jump and pass. So inside your, yeah, I can do it in the way that the panel wire should pass through under the panel. Get the breaker. Let's get the breaker. Come, Daniel. I have to come to the bottom of my car. Get the breaker. Almost.
So we are here for what?
We are picking breaker and we are not making use of it. Here we have a frequency inverter for now, which is not in use. So we're only having the same installation we have there. Is also 5 kVA inverter. This 5 kVA DC pump, and it's connected to 30 solar panel there on the sides. So that's what it's for. And the pumping machine, as you can see here, is being active. And as it's pumping to one of those water reservoirs. We have the dormant breaker that we are going to use. Oh, okay. Let's borrow this guy. Sorry. Don't stress me. No, I'm getting simple. What is? energy connected to this.
Okay.
But I just want to do it well. That's why I'm doing a insulated tip on it. How many minutes do I have on that video now?
36.
Huh?
36.
Ah, that's huge. But no problem. This is so good. We are done. What we need is just this breaker.
So you want to transfer that breaker to the other one?
Yes. We can be able to put it on and put it off if need arises. This is a temporary installation. That's what we need. Yes, I want more coming. I know. So now I'm going to color code this positive and negative. So this will be the negative wire or the supply wire from the breaker. This is 3-pole breaker, but we're usually using a 2 pole from it. 1 pole will be useless now. The electrical, we have 3 color coding: red face, yellow face, and the blue face. Okay. Yes, so for the 3 phases that will carry the power face. For here, supposed to be red face, yellow face, and blue face. So the DC side of the pump is face. It's 1 face, it's not the 3 face. Usually the AC side, that's the grid side. That is on the 3 face. Then the neutral, usually always on the machine. The machine has the neutral inside. It's encoded. Okay. That's the reason why we should use a selector groove. The reason for this is so that we can have control. So putting on the water and off in it. Okay. So you can use any of the choice and select which of you want to be on the positive side.
Any of it can be used.
Any of them can be used, but what you pick from positive should be your positive from down. What you pick from negative from up should be your negative from down. So don't do a reverse polarity to avoid disastrous situations. Using this one as my negative. Am I now? Also replicate that on the bottom to avoid a very tough situations. So you grab, you know whether it's firm. So now let's bring back the so the electrician will run the heads. Yes, you already connected to there. Tell them to do that. Okay. Positive side now. So I told you I'm just going to open it. And these are wires. It's not quality enough at all. I will encourage them to buy a good wire. When the times come. And most times, when many customers have their equipment damaged, installers will recommend something for them to do. They will not follow instructions. They always felt that they want to be cheated and they can get it cheaper, they can get it best. But you go to the market by yourself, you can't get the best. You understand? So those are our clients there in the market because they are interested in selling their business. They are not a professional. They're just a businessman. So they will give you what they want you to buy. And you go and get your equipment damaged. But sometimes too, customers may give a misinformation to their vendor maybe. Or I feel it's also the responsibility of the vendor to give you quality. See, this is the positive line, this is the positive line. So the negative line goes to the reverse line. To avoid the reverse polarity, which can be very deadly. Okay, so try to know whether it's firming up. So now we have that our positive and negative here. Where's the meter? Inside. So I've not put it on.
No, nothing.
Nothing. So until I plug the meter for me. Okay. Hold the other one. Let's come closer, please. We have It's correct. Come in. It's correct. So that's you might call it Int'l fire. So now on the PV side, that's China.
Let me touch you.
No, I have off
You have off it.
Yeah,
Okay.
I have off it. Are you scared?
It's necessary. Based on what you have earlier said.
Yes.
Don't play with
Fire. Okay. So now we have P plus, we have P minus. So the P plus is the positive terminal. Okay. For the PV. Why is P is that it means PV. PV means solar panel. So PV. What Chinese people have done, just panel, nothing inside. Because you can get it cheaper. They feel that someone that may give you a very good quotation, you will not patronize him because you felt you get it cheaper. You're going to go and buy China. And when you made it China, start showing you pepper. We also have PE. That PE means P8.
okay.
PV8. So where you're supposed to put the 18 part for the PV. Okay, there's a surge, but they will come and connect at the electrician. The electrician will come and connect that for them, or when they are doing their.
But on a normal installation, it's supposed to be done together.
Yes, but. Alright, it's time to test the PV. Try to pull a bit. Water is even. Sun is not really out. Are you hearing the sound? The sun is down. And the weather is not strong enough to pick it. It's coming up a bit. Look at the sun is so down. sun is down. Okay, sun is coming up now. Okay, now the sun is coming up. So it's trying to peak. Alpha, the president is not moving. Yes, so Alaga. Like you're not playing Kisha. It's the sun. That's the capital of the sun is. That's the disadvantage of this system. The sun, you know where the water is coming from, the depths. It's very far. How many meters? This pump. Ole? You can see. They are pumping where with what? Solar panel.
The solar is not working.
Don't you care? Let me take it down. We are done. And let me call them that we are done with our work. So they can come and see. So now, going we are done officially. Any questions, sir?
So what is the advantage of this other one?
Not seeing any proper work is coming to that panel. When it's on the ground, it may be blocked by shadow, may be blocked by dust, but on the roof, it's safer there, and nobody can do it. But if it's properly installed, that is what the experience of us are
Very fascinating, very empowering, and it's a nice work. What you are saying is the fear that some people exercise because of installing on the roof is moving. It's properly done. There's no fire. Well done. Alright. So we'll let other people know about the benefits of installing solar panels.
Thank you.
And can you tell us again the name of your company and your phone number and where you are?
Yeah, my business name is Icon Rose. There's also a that Icon Academy is regarding number 081 37 037 627. I take that again, 081 37 037 627. So please call us. I prefer you WhatsApp us. Drop the WhatsApp message for us because you cannot attend to all the calls. Tell us your location, what you want to power, and then you can do voice notes. We'll definitely attend that. Thank you. Love you so much. Then we're going to bring to your way our total package of energy we have here. We are going to do that shortly. All right,
and the video will be very interesting.
Oh, very, very